Hello everyone, problem number 1. So in this problem we are given an array of integers and we have to find the largest sum of elements that are next to each other. So basically it will be the calculation of largest sum of contiguous subarray within this one array. And for example, in this given array, the maximum number of elements that are next to each other where can find here, and it will be equal to 8. So one way is to find solution to this problem is using double for loops, but the double for loops is not most efficient way because time complexity of double for loop is n of n square, and we have to find more efficient way, and one is just to use the Caden algorithm. And here we have to define two variables. One is max so far, which we will define as the minimum value, and another maximum value variable, which we will define equal to 0. And how we're gonna calculate this? So each time we will take one element from an array and sum up it to the with the digit that is kept in under maximum value. So right now our maximum value is equal to 0. We will just increment it with the first element, and it will make it equal to 1. After that, we will check if our maximum value is greater than the max so far variable. If it is, we will just redefine our max so far with the greater value from the max value variable. So in this case, our maximum value is greater than the most minimum value, and that's why our max so far also will be equal to 1. So after that we'll go to the next element of an array and increment our max value by this element, which is -4, and it will make our max value equal to -3. We check if it's greater than max so far current value. It's not, so our max so far will be untouched. But since our max value now is negative, so it's less than 0, in this case we always reset our max value and we'll make it equal to 0. So we go to the next element, which is 3, increment our max value with this 3, and it will make our max value equal to 3. And we check if it's greater than max so far value. Yes, it is. So we are changing our 1 to 3. And we also check if it's positive or not. It's positive, so we go to the next element. We see that it's -2, so -2 plus 2, 3, and it will make our max value equal to 1. Is it greater than max so far, which is 3? It's not, so we are checking just if it's negative or not. It's not, because it's positive. So we go to the next element. It's 7, so we're decrementing our current value by 7, and we see that now our max value is equal to 8, and we're checking if our max value is greater than the max so far value, which is 3. Yes, here, so we're defining this 8 to max so far. And since we are reached the end, to the last element of the array, we're just returning at the end the max so far value, which gives us the largest sum of contiguous subarray of the given array. And so let's go to the code, and it will look like in the following way. I will call it largest sum. The input will be just an array of integers. So at the beginning I will define these two variables. I will call them max value and will define it equal to 0, and another will be max so far, which will be equal to the most minimum integer value. After that I will use for loop starting from 0 index, go through all elements of an array and I will just increment my max value by elements from the array, and after that I checking my max value under if conditions. If it's greater than max so far, I'm just passing that value to max so far. Then after that I'm checking if it's still positive or negative. If it's negative, I'm just resetting it and setting a 0 to it. So after that I will just return max so far value, and time complexity of this algorithm will be order of n, because we're just going to the once through array, so the number of operations will be the number of elements in the array, and space complexity will be constant because we're just defining two integers. So thank you.